In part 1, we talked about integer variables, and we even wrote a very little program that uses an integer variable. Here it is. Although this program is only 2 lines long, we can run it. But I warn you, it won't do much. If I run the program, I'm not actually asking it to draw any graphics. I'm not asking it to print anything out or make any sounds or control any robots. I'm just creating an object and sticking a number into it. So I've run the program. You can see processing has created a default graphics window for me, which is awfully nice of it. It always creates a graphics window because it figures you're going to want to do graphics. But otherwise, nothing happened because I haven't asked it to actually do anything. But the code ran. That's a running program. So I'm going to stop the program, and I'm going to assign a different value to number of star cookies. Let's suppose that we bake another batch of 5. Now we have 10 star cookies. So we took the car off the shelf, we changed what was inside, we put it back up on the shelf. This object, because it can change or vary over time, we can take its value and stick new values into it. It's called a variable. In fact, any object in your program that you create that can hold a value is called a variable. And you'll see you're going to create so many variables over time. So let's look at this just a slightly different way. Think of the variables in your program like the lockers in a locker room. Each locker has its own contents, which are different than the contents of all the other lockers. And each locker has a name, so we know what stuff is inside of each locker. So let's, for example, take a look at this little set of lockers, and let's think about the one in the upper left. Let's suppose that that's holding the value of number of cookies conceptually. So let's look inside the locker. We open it up, and there's nothing inside right now. So, I guess there's a pair of shoes, but let's assume that there's nothing inside. So we close the locker, and we know the locker hasn't got anything inside. So this is like the case when we have just created the variable. We said int number of star cookies. It doesn't have a value yet. There's nothing inside of it yet, so it's this empty thing. Now we open it up, and we put in a gray jacket. That's equivalent to saying number of star cookies equals 5. Now we close the locker, and we walk away, and it's got the gray jacket inside of it. Now later we go back in, we open it up, we take the gray jacket out, and we put a yellow jacket inside instead. Well, that's like saying number of star cookies equals 10. We've now just put a different value into the locker. And we close it up and walk away, and once again, the locker holds the new value. So let's return to the processing example I was giving you. So this first line, where I tell the computer we have an int called number of star cookies, this is called a declaration. We're declaring to the computer that there is a variable called number of star cookies, and that variable is of type int. And so int, we say, is the type of the variable number of star cookies. If that language doesn't gel in your head, don't worry about it. It's not real technical. You can say it pretty much any way that makes sense to you, and everyone will understand. But that's the formal language, and that's the language I'll use. And my guess is you'll get used to it just from hearing me say it. So once again, number of star cookies is the variable, and int is the type of that variable. And now we're putting values into the variable using the equal sign to assign a number into the variable. This is called an assignment statement. Not much of a surprise. If I want to give number of star cookies a value right off the bat, I can do that. I can save myself one line. So let me hit a blank in here. Actually, let me delete this blank line. So these first 2 lines are doing 2 separate things. First one says create the variable, make it an int. Second one says put the number 5 into it. Well, at the time of declaration, at the time of creation, if you want, you can actually give the thing a starting value. Just like that. Whoops, the semicolon goes on that line. So now I'm saying, all in one go, I've got a thing called int number of star cookies. It's an int, and it starts with the value 8. And then we put a 5 into it, and then we put a 10 into it. Let me show you one other thing we can do to wrap up. I can say number of star cookies, and as we've seen, something can go onto the right-hand side, and whatever is there will get put into the left-hand side. Well, let's suppose that someone gives us 3 more star cookies. Somebody else helped out with the baking. So now how many do we have? Well, we have 3, the new ones, plus the old value. And this is a good line of processing. This does the trick. The way to read this line is from right to left. In fact, the way to read most lines with an assignment statement in them is right to left. If you see that equal sign, focus on the right-hand side of the equal sign first. So in this case, we see the equal sign, we go, okay, start off on the right. Then value of number of star cookies, whatever's inside of there, in this example, it would be a 10, gets added to 3. Well, that makes 13. And now that gets put into number of star cookies. And so number of star cookies, when we're done with this line, now has the value 13 because we read from right to left. Now, as you can guess, we can do all the other math. We can do addition and subtraction, multiplication, division. We can do lots of other things, and we will get at them. But this is the basics of how to declare and use an integer.